I'm going to look at how we can convert a database table into second normal form, given that it's already in first normal form. So to understand what a database in second normal form looks like, well, first of all, it needs to be in first normal form, so data are atomic, there's no repeating groups of attributes, but also it needs to be the case that there's no partial key dependencies of non-key attributes. Now that is a bit of a mouthful, and understanding what that means is a tricky idea, so hopefully in this example here we'll try and break that down and explain what is going on there and how we deal with this idea of no partial key dependencies of non-key attributes and how we determine whether that's true in a table or not. So given our database here at the bottom there, so that's table there is already in first normal form. This was demonstrated in a previous video as to how this was done, and explained also why it's in first normal form. In the table above, this is what I've created, and what I've got there is I've got 3 columns here, but the interesting ones are the student ID column, which is the primary key, and also the course code, which is also primary key. Remember, this is a composite primary key we have here, so we've got 2 primary keys making up the two attributes making up the full primary key. And then for each of the rows then I've got the non-key attributes, got student name, course, teacher name and teacher phone. So what we're going to do, we're going to go through each of these non-key attributes and determine whether they are dependent on each of these primary key attributes, whether dependent on student ID or course code. So to begin with then, we'll look at student name and determine whether it's based or dependent on student ID. Well, it is, because given student ID of 1, student name will always be Alice. So student ID 1 is Alice, student ID 1. So based on the data in the table, you can see that's the case. Intuitively also, we'd expect that to be the case. So given the student ID, you'd have the same student name. So intuitively it makes sense, but we're not really talking about intuition. We have to look at the data to be sure that this is the case. We always have to be really careful in this context. So we've got our student name, we know is dependent on student ID. So given the student ID, we can determine what the student name is. That's the summary of that. Next, we're going to look at whether student name is dependent on course code. Well, if we look at course code and student name, so given the course code, let's say MA for maths, well, student name can either be Alice, or it can be Bob, or it can be Charlie. So we're saying it's not dependent. So student name is not dependent on course code. Again, intuitively, that makes sense. But again, we're not basing it on the intuition, we're basing it on the data we have in our table. So next we're looking at whether course is dependent on student ID. So if we look at student ID 1 here, well, you can either have course maths or course history. So again, course is not dependent on student ID. Next one up is whether course code and whether course is dependent on course code. Intuitively, yes, it is. But again, looking at the data also confirms that it is. So given the course code of HI for HI, we're always going to have history against it. You can see that in both the cases here. And also same for maths, given course code MA, the course is always maths. Next one then, teacher name. Is teacher name dependent on student ID? No, because for a given student ID, let's say we take student ID 2 here, we've got 2 different teacher names. We've got Mr. Jones and Mrs. Lee, so it's not dependent. Next one to look at is whether teacher name is dependent on course code. In this context, yes, it is. We could have it such that we have multiple teachers for a given course. There's nothing wrong with that, but remember, we're basing this on the data, not making any additional assumptions or any other intuitions. We're basing it solely on the data, and based on this data, we have 1 teacher teaching each course, and in actual fact, we have the same teacher teaching multiple courses. So in this case, we can say that teacher name is dependent on the course code. Next one, teacher phone. Is it dependent on student ID? No, because again, for a given student ID, we can have different teacher phone numbers. Again, if you look at student ID 2 here, we've got two different phone numbers, 0987, and we've got the other one, which is 1234. So no, they're not. It's not dependent. And then finally, we're going to check to see if teacher phone is dependent on course code. If we look at the course code here, let's say we take maths, we'll see that the teacher phone number is always 1234, starting with 1234 in each of these cases. And if we went through each of the other course codes, you'd find the same thing as well. So the teacher phone would be the same given for each given course code. Now that we have created our nice grid that determines which of our non-key attributes were partially dependent on the primary key, what we can do then is we can split our table to put it into second normal form. So we can see that student name, our non-key attribute, is only dependent on the student ID, so it's only partially dependent on the key. Whereas course, teacher name, teacher phone are only partially dependent on the key because they're only dependent on the course code. So what we're going to do is attributes that are partially dependent on student ID will go into one table. Attributes that are partially dependent on course code will go into another table. So this is what our student table looks like. So student name, student ID, those attributes go into one table. Remember, student name is dependent on student ID only. Then we have the next table. So this is our other table now where we've got the course code, where course, teacher name, teacher phone were dependent on that attribute that made up the primary key. So we've now created two tables, and we've taken all those attributes out of our original table, and all we're left in our original table is student ID and course code. So that now is our database in second normal form. If we create an entity relationship model of it, this is what we get. We get a many-to-many relationship with our students table. We've got our subject table, and then we've got a linking table then with our student subjects with our original student ID and course code. They were our original primary keys, the composite primary key that we had. So that's the only remaining attributes left in that table.